All right, so we are evaluating a limit as x approaches infinity. So there's a long way to do this that's official, and then there's the, hey, this is multiple choice and I get how these things work way to do this. The way to do this when you're looking at multiple choice is to realize that as you approach infinity, you really only care about how the leading coefficients are behaving. So this numerator, so this isn't equal to, but it behaves like, for very large values of x, the square root of 9x to the fourth on top of an x squared. Well, we can clean up that square root of 9x to the fourth, and we would get a 3x squared over an x squared, meaning that this thing behaves like a 3. And that's it. There is a mathier way to do this, right? And you're certainly welcome to do it. And on free response, maybe you'd be required to, but on multiple choice, your job is to be able to get to the right answer. The mathier way to do this is to essentially multiply the numerator by this quantity and the denominator by this quantity, right? And what's going to happen, right, if you multiplied this thing times the original, is you're going to get that this is the limit as x approaches infinity. And then inside the square root, you're going to have a 9x to the fourth over x to the fourth plus a 1 over x to the fourth. And then on the bottom of the fraction, you're going to have an x squared over x squared minus a 3 over x plus a 5 over x squared. And when you plug in those x approaches infinities, since these guys cancel, this is just a 9, and these guys cancel, this is just a 1. But when you plug in the infinities, this, and this will all be 0, because when you have a finite number over something infinitely large, it's 0. So you end up getting that this is a root 9 on top of a 1, which is just a 3. But again, you can intuit it a lot faster in a problem like this.